Negative 3.757.
Yeah.
Great. Now I want you to notice something. Have you noticed until now, every image distance we've gotten has been positive? Now we got a negative image distance. What could that mean?
The distance is the other way. Imaginary.
How many people are thinking that means it's a virtual image? Hey, good for you guys. And I want to tell the world that almost every hand went up. Good. Let's go ahead and get the magnification. Magnification, which is negative d sub I over d sub O, which is negative 3.75 over d sub O, which is 1.5. So what did you guys get? What's the magnification? 2.5? Okay, 2.5. Look at that. The magnification is positive. Until now, every magnification we had was negative. What does a positive magnification tell you?
The image is large.
Not that it's enlarged. Yeah, it's upright. Thank you, Brian. The image is going to be upright. What about this number tells me that the image is also going to be enlarged?
Greater than 1.
Yeah, it's bigger than 1. So because this number is bigger than 1, I know the image is enlarged. Because the number is positive, I know the image is going to be upright. And because this image distance is negative, I know it's going to be a virtual image. Let me show you how that shakes out. You're going to do a ray drawing momentarily, but I want to freehand the ray drawing for you to show you what it ends up looking like. Then you'll do it more carefully. Here, principal axis, mirror, focus, object.
Supposed to copy this?
Center of curvature. I'm freehanding it, you guys are going to be careful with it, but I want to show you. Do you remember where before, because my object was to the right of the center, I had to have a line going through the center and then through the object and then straight back? Look here. Not only is it to the right of the center, but my object is also to the right of the focus. So let me show you what those three rays would look like. Ray number 1, which I always draw in blue, is going to go from the center through the object, hitting the mirror, and then coming straight back. This is ray number 1. Ray number 2 starts off parallel to the principal axis and then passes through the focus. So this is going to be parallel to the principal axis. Then it's going to pass through the focus. Here's ray number 2. Ray number 3 goes through the focus, hits the mirror, and comes off parallel. But you'll notice my object is to the right of the focus. So just as I did with the center, just as I did with ray 1, I'm going to have to start from the focus. I'm going to start from the focus, pass through the object, hit this mirror, and then come off parallel. Oops. Did I kind of mess up the parallelness? Okay. Now, let me ask you this question. My eye is right here. This is where my eye is. And I'm seeing 3 diverging rays. These rays aren't coming together like they did for the previous 2 problems. These rays are diverging when they hit my eye. Well, they were diverging when they hit my eye too, but when I work backwards, I got an image that was over here. Here, the rays are diverging when they meet my eye, but when I work these rays backwards, where are those 3 rays going to meet? Yeah, behind the mirror, behind the looking glass.
They would.
When I work the rays backwards, I'm going to get that ray, this ray, and this ray coming together behind the looking glass. You see? What kind of image do I have there?
Virtual.
Virtual. Those aren't real light rays coming together to make that image. I'm just working backwards. That's where I think the image is coming from, but real light rays aren't coming together to make that image. Also, please note, is this image inverted or upright?
Upright.
Upright. And of course, you see it's enlarged. So now, I would like you to please do the ray drawing for this. And you'll have to be more careful than I was, but it's just the same idea.
Do the
So
ray
good luck
drawing.
on the ray drawing.
The ray drawing.